Well, good day, subscribers. Today is going to be part 6 of the 7-part series, How to Build a Robinhood Auto Stock Trader in Python. In today's video, we're going to make a grapher file that is going to graph the output of our trader as it trades throughout the day. So let's jump in. So we have done a lot in this series. We built a trader, grapher.py, that connects to Robinhood to get real-time stock information. We added in a trading strategy, tradestrat.py, to decide when to buy or sell stocks. And now we're going to build a graphing file, grapher.py, that will graph the output of our trader and give us visual feedback throughout the day. In today's video, we're going to make the file, and in part 7, we're going to integrate that file into the trader. Now that we have our outline of what we want, let's pick up our favorite IDEs and get started. Alright, so here we are back on the desktop. We have our IDEs open over here. I'm using Atom, and our CMDs open over here. Now, for this video, we're going to be building the grapher.py file. And this file is going to give us a visual representation of what the prices of the stocks we're looking at are doing and what our trader is doing when it's buying and selling. Now in this video, as I go through it, I'm going to be showing some results from my CMD that'll better explain what we're doing in each part of as we build the grapher file. You guys won't be able to get these results because before this video, I did some preparation on my trader file so that we could actually see the results as we're building the grapher. Now you'll see these actual parts integrated in the next part, part 7, when we integrate the grapher into our trader. But for now, just follow along and kind of walk through the logic in your head. And then in the next part, we'll be able to integrate everything together and you'll see the final output. Now, before we jump in, let's just look a little bit about what we did in the last video. In the last part, part 5, we added actual sell and buy commands to our trader so that we could sell and buy on the live market as stocks changed. And we actually made a little bit of money. So we added our real sell command and our real buy command. And if you'd like to see how we did that and integrate it into the trader file, go back and look at part 5 of this series. So for now, let's move over to our grapher.py file. So this is going to be a new file, and like I said, this file will hold everything that we need to give the output of a live updating graph of what's happening to the prices of the stocks we're looking at, as well as when our program is making buy and sell commands, and it's a really cool output. So the first thing we're going to need to do is add our imports. So we have 3 imports in this file. We have import matplotlib as PLT, import pandas as PD, and import datetime as DT. So for anybody who has done some work in Python, particularly in data manipulation and databases, these 2 files should look very, these two libraries should look very familiar. Matplotlib is a particularly fantastic graphing library, and it's really my favorite to use. It's very easy to use, and I've become pretty comfortable with it. And pandas is a great great library to use when you are working with databases. And we're going to be building these databases for the prices and for our trades. And then we're going to be using matplotlib to actually graph these databases. So the first thing we're going to do is we will start off by adding our first function, which is going to be normalize. So before we get into how this function works, let's talk a little bit about what normalizing is. So normalizing is the process of dividing a stock's price by its original starting price, and therefore getting everything to be normalized at 1. Now what this means in actual functionality is if you have a stock that starts at $100, throughout the day moves to $105, and then later in the day moves down to $95, you would divide all of those prices by the starting price of $100. So on your graph, what you would see, instead of seeing a stock that goes from $100 to $105 to $95, you'll instead see something that goes from 100 divided by 100, to 1.05, 105 divided by 100, to 0.95, 95 divided by 100. In that way, you have everything normalized around 1. Now, why is this so useful? Because in our program, we're dealing with stocks that have many different starting stock prices. So we might be looking at one stock that starts off trading at $1.50 and another stock that starts off trading at $5. And we don't want our graph to be so tall on the y-axis that we can't really see what's happening throughout the day. We want everything normalized to a central point because we don't actually care if the $5 stock goes to $10 or if the $1.50 stock goes to $3. That's both an increase of 100%, right? We care about what is the change in the stock. So if we normalize everything to 1, if the stock goes from 1 to 1.05, then that stock increased 5% no matter what the starting price was. And that way we have a nice compact graph in the end that is much easier to read and much easier to see the changes throughout the day. If you'd like to see any more information on this, there are tons of videos on YouTube. You can just type in normalizing of a graph, and I'll try to put one in the video description as well. So what we're going to be doing here is we're going to be taking a data frame, right, and we're going to normalize it. Now, just to start off, I'm going to show you what this data frame actually looks like. Now, you guys, like I said, won't be able to get this output yet. I've done a little bit of work in my trader file so that you guys can see what we're doing as we're doing it. But you guys will have all of the information if you watch the last part of this series, part 7. But for now, let's just see what we're going to be working with. So as we run it, we get INPX. And CNET, we get the holdings, we get the price and our trade for that stock, which we all did in the last video, part 5. And then here we have this new part. So we have the data frame, we have our 2 stocks up here, and then we have the time and the stock's current prices. So INPX is trading at $1.01, $1.01. And CNET is trading at $1.32. And if we keep running it, it'll keep adding rows. So let's just take a quick look at that so you guys can see. All right, so as you guys can see, as time goes on, it adds a new row with an updated time and the updated prices. Now I'm recording this video on Sunday at about 3:30 p.m. So the stocks obviously aren't being traded right now, so the prices aren't going to change, but you'll be able to see how it updates and adds new rows. So as time goes on, our database grows bigger. And as you can imagine, as our database grows bigger, our output graph is going to look larger. So let's just let one more row add in. All right, and there we have the third row. So 30 seconds apart, and the prices stay the same. Okay, so now we kind of have an idea of what this data frame is. It's our stocks as the columns and our prices for each row with the time as the part right here. So the first thing we're going to do is we're going to take a look at normalizing based off of the first section. So before I do that, I just kind of want to show everybody this function that we'll be using a lot called shape. So what shape does is it's going to tell us the size of the data frame that we're working with. So just to show you guys what that output's going to look like, let's run it. And it gives us this thing, 1, 2. And what that means is starting off, our data frame is 1 row long because it just has this first row and 2 columns. So it's a 1 by 2 matrix. And just to show you how this changes, let's keep running it. And as time goes on, it'll go from 1, 2 to 2, 2, then 3, 2, then 4, 2, as more rows are added on. And I'll just show you guys that right now. So as you can see, now it updated and now it's 2, 2. And if we kept letting it go, that row number would just keep growing. So let's stop it and clear it. So just to remind us, we'll add a little comment. So we'll do df.shape gives rows, columns. And that way we'll just remember that as we're building the rest of the function. So the first thing we're going to do is do an if-else statement, and we're going to have if the length of the data frame shape is equal to 1, or the data frame shape part 1 is equal to 1, then we're going to normalize the data frame based on that first value. Now let's take a quick look at what this all means, because this might be a little bit confusing. So if the length of the data frame shape is equal to 1. So when we output the data frame shape, we get a tuple with 2 different sections, rows and columns. What this is saying is if the tuple only has 1 column, then we're going to run this part. Or if the shape of the first part, so the column part, is equal to 1, meaning we're only looking at 1 stock, then we don't have to think about what each one gets divided by. We can just divide everything in the data frame by the first row, which is going to be the price, and we'll just get a normal data frame. So this is only in the case where you have 1 stock that you're looking at. I added it in. I do find it helpful, but this part is only for when you have just 1 stock that you're looking at. So now we're going to add the other case. So the first thing we're going to do is add df normalized equals pd.dataframe, and pd is our call to the pandas library from before. Data frame, so it's going to create a new empty data frame, and we're going to take trading days is going to be df index. So we're going to have index is that farthest left column. So it's kind of the way we're going to call each one of these things. And what this means is on a particular trading day, that's going to be the index, meaning when we want to know, let's say, the price of a stock at a certain time, we'll call its index. So now we have for stock in df columns.values.toList. So what this is doing is taking each one of our stocks and taking the column and making it into a list. Now we have df normalized of that stock equals pd.series df of that stock divided by df of the original price of that stock. So here we see something similar. We see df of that stock iloc 0. And here we have a very similar thing, df iloc 0. So remember in the last part, I said this is only if you have 1 stock. Well, if you have 1 stock, you don't have to specify which stock. If you have multiple stocks, then you have to specify what number you're going to divide each number by. So in this case, up here, we just have the only stock that we're dealing with divided by its value. In this case, we have stock number 1 divided by stock number 1's original value. Then we'll have stock number 2 divided by stock number 2's original value. And that way, everything gets normalized to 1 in the beginning and then either grows or shrinks depending on how that stock does throughout the day. And then we just have, again, comma, index equals trading days. And then we just have over here, index equals trading days. So let's take a quick look at that just to make sure we understand this whole else part. So the first thing we do is we create an empty data frame. Then we say trading days is going to be our index. Then we go through each one of our stocks in the columns. So each one of the stocks that we're dealing with, and we normalize the price for each of those stocks. And we do that by calling pd.series of the data frame stock divided by the starting value for the data frame stock and indexing it by our trading days. Now let's take a quick look at the way this looks and what we're going to be actually returning. All right, so this is going to be print. We're going to print the df normalized. We'll do that /n, so it's on the next value, the next line, and df normalized. And I will show you guys one more thing. So this, if this first part is run, I'm going to print if was run, and if this else is run, it's going to print else was run. And what I'll show you guys here is just, since we're currently looking at two different stocks, INPX and CNET, it's going to run this else statement, and then I'll switch it so it's only looking at INPX, and you'll see that the if statement is run, just so you guys can see that what I was saying was true. So let's take a quick look at what this is going to look like. Again, remember, the outputs that I'm getting in my CMD, you guys won't be able to get as you're following me along in this video. The reason is, like I said, I've done some work on my trader strategy, or on my trader file, to get these outputs. They're not, and you'll get those same changes in the next video, part 7. But for now, I just kind of wanted you guys to follow along with me. So let's take a look at what that's going to look like. So we have INPX and CNET. We have our usual outputs, and then here we have our pandas data frame. So we have df normalized, and we can see that everything is normalized to 1, which is fantastic, exactly what we wanted. So we have the current time, and INPX is normalized to 1, and CNET is normalized to 1. And if we look up here, INPX is actually trading at $1.01, and CNET is trading at $1.32. But since we divided them by their numbers, we get this value of 1, which is a normalized value. And if we look right here, we have else was run. So this was a case, since we had 2 columns, it didn't run this if part, it ran the else part. So I'll just let it update to the next row so you guys can see. And as you guys can see, now it has 2 rows and it's still at 1. The price is not going to change because we're looking at this on a Sunday. So I will end this, and then I'll go over to my trader, scroll up to my stocks. I'm going to comment out CNET. And now when we run the grapher, it's going to run the if statement. So here you guys can see it says if was run. So if you guys know that you're always going to be only running this program with more than 1 stock, you don't actually need this if statement, and you could just have the second part. I added it in because as I was doing testing, I wanted to just make sure that I would never have any kind of weird errors, but that's up to you guys and can be your personal customization of this file. So we will close this out since we showed that the if was run, and we will go back here and add in our CNET again. All right, and let's get rid of these print statements. Okay, I'm going to keep that there. So now we're going to add the second function that's going to go into this, and this is going to be called def active graph. So the reason I called it active graph is because it's an actively updating graph. Passive would mean it is updating after the information comes in. Active means as the information is currently changing, the graph is currently updating. So it's really interesting to watch. You'll see stock prices go up, stock prices goes down, and where your trader is making buy or sell. So we have def active graph, and we're going to pass in 3 attributes. We're going to pass in our data frame trades, and a pause. Now the pause is just a quick thing, just a 1 second pause. And this is just to allow the graph to update. Let me quickly explain what each of these are. So we have DF, which is our normalized data frame from up here, which is going, so it's our prices. And then we have DF trades, which comes from our trading file, our trader.py, and that's the actual trades, buy, sell, or hold. What we're going to do is we're going to combine these two data frames, and we're going to create a graph that has line graphs as the stock's changing price and vertical lines as our traders buy or sell commands. So the end result is going to look really cool. So the first thing we're going to do is we're going to build our graph. So this is basically all coming from matplotlib, which is right here, matplotlib. And so we have plt.clf. So these two things right here are kind of just to clean the graph. And what that means is every time we update the graph, we have to clean the old graph and then build an entirely new graph. I couldn't find a way to just add onto the old graph. So what we do instead is we kind of destroy the old graph and then very quickly create a new graph with the new information. So that's what these two things do. So if you guys want to look them up, you totally can, but it's plt.clf and plt.ion. Then we're going to title our graph. We're going to call it active graph. We're going to add a label to the x-axis called time. We're not going to have any tickers on the x-axis since it's going to be constantly updating. And then we're going to do a label for the y-axis, which we're going to call normalized prices. And now what we're going to do is get into how we actually build the file. But before I do that, I'll add the last part in just so you guys can see the graph without any information added. So this is going to be the bottom part of our function. So we're going to add a legend. A legend is just a little section in the graph that kind of defines all of the different things the graph is showing. And we're going to do that by doing plt.legend df, which is our price data frame, .columns, .values, .toList, and we're going to lock it up to the upper left side corner. Then we're going to draw the graph, and then we're going to save the graph to our desktop and save it with today's date as the file name. Now, this part right here, you definitely don't need if you don't plan on saving these images for any particular reason, but I save them just so I can have them and look back if I ever want to. And then we're going to pause for the amount of time that we specified here, which is just 1 second. And the reason we do that is to kind of give the program a second to reset, and then it goes back. So now we're going to run it and just show what an empty graph is going to look like. So if we run it, we have our stuff come up, and then here is our graph that's going to pop up. It has the title that we added, active graph, and the X and Y axis labels. And as you guys can see, there's no information currently on the graph, but this is kind of what's going to come up and what's going to update. And if we look over at our CMD, we have our normalized prices. So let's get out of this. And to shut down the graph, you can't exit out. What you need to do is just stop running the file. All right, so now we know what a blank graph looks like. So let's start building that data frame. So as we build the graph, it'll actually show the prices of our stocks. So what we're going to do is we're going to do this first section where we loop through each of the stocks. So we do for stock in df trades.columns.values to list. So all this, we've seen this a couple of different times. All this is doing is taking the columns of our data frame and turning it into a list so we can loop through it. If you guys want to look more into that, you totally can, but all it does is take the column name, so we have INPX and CNET, and it turns those into a list so that I can loop through them in the program. And now we're going to build up our trading part. All right, so we have if DF trades, which is our data frame that's built from our trades. So it's either going to say hold, buy, or sell. So we have if DF trades for that stock, I lock the most recent one, meaning, so what iLock does is it picks a specific spot on the data frame. So iLock -1 means we're locking in the last most recent value for whatever position we're saying. So we're saying, what is the most recent command we've gotten for the stock that we're looking at? So the first time it'll run, it'll say INPX. So for the stock, we're going to be looking at INPX, and then it'll say DF trades. So what was the most recent trade our trader told us to do for INPX? If it is hold, or if it is buy, then we're going to plot onto our graph that stock with alpha equal to 1. Now this might look a little bit confusing. This is all stuff you guys can read up on in terms of matplotlib, but all alpha does is it either makes the graph show as 1.0 is fully solid, and down here we have 0.2. Now that is going to show up as very dull. And what this is going to do is, as the graph is updating, it's going to show us which stocks we're currently holding and which stocks we're not holding. So as we show the output, if the line is a solid color, then we're holding that stock. If it's a dull kind of sort of see-through color, then we're not holding that stock. So we have, if it is hold or buy, then we're going to print out the line as solid. Else, if it is wait, you guys haven't seen this wait part yet. We're going to build it in the next part, in part 7. But for now, you guys can just follow along. So wait means we are not holding the stock and we're not going to currently get it. So now we have kind of 4 commands. We have buy, sell, hold, or wait. So if you currently have some of the stock, then you can hold it. If you don't own any of the stock, then you wait. And so this is kind of saying the same thing. So DF underscore trades for that stock. If the most recent command we've been given from our trader is to wait, then, or to sell, then we're going to plot it with an alpha of 0.2. And just to show you guys again what this looks like, there you guys go. So if we are holding it or we currently own it, we're going to plot it solid. If we don't own it, and if we've either sold it or we don't currently own it, we're going to plot it with a little bit of see-through. Let's take a look. And now we can see the legend up here that we added. And if we wait a little bit of time, you'll see the graph update with some lines. So let's show that. And here we can see a line, and since we're not currently holding any stock, as you guys can see up here, we're holding 0 and 0. It's kind of a see-through line. So let's end that and let's finish up the last part, and then we'll close out this video. So the last part, here we have, move this over a little bit, and so now we have for day and order in DF trades. If order for the stock is buy, we're going to add a vertical green line. And if order for the stock is sell, we're going to add a vertical red line. So what this is going to do is, as our graph is building, if our trader tells it to buy, it's going to add a vertical green line. And if it tells it to sell, it's going to add a vertical red line. Again, everything in this kind of section is all about personal preference. If you wanted to use different colors, you could use different colors. If you wanted to use different amounts of intensity of the line, you could change that. You could change the thickness of the line, or you don't have to add this part at all. It's entirely up to you guys. But I did add it because I found it to be the best visual representation of what my trader was doing. So now if we run it, we're going to have our full graphing file. So let's just do that. So since right now it is Sunday at 3:50, and if I run it, the prices won't change at all, I'm going to hold off for now, and I'm going to come back on a day where the stocks are trading so you guys can see as the graph updates and kind of shows different values. It'll be a little bit more interesting, so just wait 1 second and I'll be right back. All right, so here we are back at the desktop. It is now Monday at about 1:30 p.m., so stocks are trading live. And I just wanted to run the grapher.py file a little bit now and show you guys kind of the output, what it'll look like, and then we'll kind of talk about the graph a little bit. A couple of notes before we jump in. So first of all, I did add a couple of extra stocks into my stock list. This was just to make the output graph look a little bit more interesting. Instead of just following 2 stocks, INPX and CNET, I added a few more stocks just so we could track a couple of different stocks instead of only tracking 2. Second of all, it's important to remember that I added some code that you guys will get in part 7 of this series to my trader.py file that actually makes the graphing program work with the trader program. Like I said, that'll be coming in part 7, which is the final part of this series. So if you guys try to run it with just the stuff that we did today, you guys won't get the same output as I do. But if you follow along and take the code from the next video, you guys will get this same output. And lastly, one other thing I noticed while I was just troubleshooting it, when I had us build the active graph function, I had this whole section over here shifted over 1. We actually want this for loop to be nested within this for loop here. So we're going to do for each stock in Dataframe trades. And then within that loop, we're going to do for day and order in Dataframe trades. And that way we're going to loop through each stock. We don't need this. That was just for troubleshooting. So we're going to loop through each stock and we're going to loop through each day in order and add vertical lines if it's a buy or a sell command. And then lastly, I just added these 2 printouts so we could watch it as it goes. And we'll be able to track the prices and see the trades that are being stored in this DF trades. So let's run it. And then after a little bit, we'll be able to talk about it a little bit. So just as we're getting started, we're looking at 4 stocks now. Here's the graph popping up, and you guys can see there's a vertical green line, which means we're trying to buy something. We're trying to buy some of this GNUS. And as soon as it lets me, I'll move this graph over. Okay, so let's just take a little bit of a look at the CMD output and then a little bit of a look at the graph output, and then I'll let it run for a while. So we're looking at 4 different stocks: INPX, GNUS, CNET, and OGI. I'm currently holding 104 of INPX and 72 of GNET, and now it just bought 72 of CNET, and now it just bought 46 shares of GNUS, and it's trying to sell some of CNET. So you guys can see kind of how the graph grows. We have a green line for a buy command, a red vertical line for a sell command, and for the stocks that I own, the line will be solid. So I own some of this OGI, which is here. I don't, but I must have just bought it. Did I just buy it? Okay. Okay, then this is a combination of 2 colors. Sometimes it does that, but let's just take a look at INPX. So as you guys can see here, I own INPX because it's solid. And if we look over here, we can see that, where is it? We are trying to buy some INPX. So it's a buy command. So now it's solid because I own it. And so I'm just going to let this run for a little bit. We'll make some buys, we'll make some sells. It is important to remember that the trading program, the trading strategy that we're running right now is a very, very basic trading strategy. Remember, it's just that price over SMA. So I don't know how well the program will do with such a simple trader. As you guys increase the complexity of your trader, hopefully it'll get better and better, and eventually you'll get to a place where you can just run this and leave, and it'll make some money. But for now, let's just let it run, and then we'll come back in a couple of minutes and take a look at the graph and take a look at our output. All right, so let's take a quick look at the graph and the output. We'll let it continue running for now, but let's just talk about it a little bit. So looking at the output, we can see here we have DF prices and DF trades. DF trades holds either a hold, buy, sell, or wait command. If it's a hold command, if we own some of the stock and we're not going to sell it yet, and it's a wait command if we don't own any of the stock and we haven't bought it yet. And so we can also look at DF prices. An interesting note, as you can see at the beginning, everything is 1. And that's because we've normalized the prices in the beginning. So we took the beginning price and divided everything by that beginning price, but the beginning price divided by the beginning price is just 1. And you can see throughout these couple of minutes, it's just IMPX as an example. It's gone up a tiny bit, then down back to normal, stayed, and then went up a tiny bit. You guys can see kind of how these different stocks move. CNET seems to be very, very steady. But you can see things like GNUS has been moving a little bit, OGI has been moving a little bit. And if we take a look at the graphing side, the graphing output that's coming from our active graph command, we can see how we have vertical green lines for buy commands, vertical red lines for sell commands, solid line graph for stocks that we currently hold, and a kind of see-through line graph for stocks that we don't hold but we're watching. And there you can see one just changed, so we just bought some OGI, it looks like. Okay, we're just selling some OGI. What are we doing with OGI? We're waiting. So this is, GNUS, is that what it is? Yes, so we're buying some GNUS, and that's why the line went to solid. So that's kind of an overview of the graph. I hope you guys enjoyed this video. Like I said, if you guys have any questions, leave a comment in the comment section. And just a reminder that we will be adding the code to the trader.py file in the next video, part 7, which will be the last part in this series, so that you guys can have this output as well. I hope you guys enjoyed it. Thanks, and subscribe.